Alright guys, so we have a quick question from the homework. I like questions like this because this question makes you really think about what a derivative is and then how to employ different properties of derivatives. Now we're going to start off pretty basic today. We haven't yet talked about product rule, quotient rule, that kind of stuff, but we have talked about how to take the derivative of a sum of two functions. So let's see here. We have instructions that say the following. Capital F equals f of x plus g of x. Okay? And the instructions are, okay, so that's what we're given. And the instructions are find capital F prime of, in this case, 2. Capital F prime of 2. Now, by rules of derivatives, what do we know that capital F prime of 2 equals? Well, capital F prime of 2, we know that if you have the sum of two functions, you can take the derivative of each of those functions individually and add the results. The derivative of a sum is the sum of the derivatives. So this is equal to f prime at 2 plus g prime at 2. This is just an exercise that makes you really think about what those properties of derivatives are, and then how do you find, what is f prime of 2 actually. Okay, so what is f prime of 2? What is g prime of 2? Well, f prime of 2, that's the slope of the tangent line at x equal 2. G prime of 2, that's the slope of the tangent line of g when x equal 2. So g, that's kind of hard to see here, but y is the red one. Oh, in fact, let me use red since it's the red line. So that's y. Oh, excuse me, not y. That's g. And the blue line is f. Okay? So this specifically is asking us to find the slope of the tangent line of f when x equals 2. Okay, so we're looking at the blue line. What's the slope of the tangent line when x equals 2? So x equals 2 is down here. Let's see, there's 1, there's 2, there's 3, 4, 5, 6, 7, 8. Okay, so let's see here. What's the slope of the tangent line at this point? The slope of the tangent line of the blue line. Now, here's the key thing. You have to understand that the slope of a linear function, is constant. The slope of a linear function is constant. Therefore, the derivative of this blue line at x equals 2 is just the slope of that line. In fact, the slope of this blue line at x equals 1, at x equals 2, at x equals 1.5, at 2.5 is the same thing, and we can find that out simply by using using our slope formula. Let's see here. Let's get some more points here. So let's see. There's a point on my line, and it has, let's see, there's 1, 2, 3, 1, 2, 3, yeah. So 4, 5, 6, 7. So this point right here is 1, 7. This point right here is, let's see, 4, 2. And we can use this point down here, that's 3, 1. And we can use any pair of those points to find the slope of that line. Okay, so just off to the side over here, the slope of that first one is, okay, let's label these. Let's just pick 2, doesn't matter. Let's pick this one. There's x1 and y1, and this one's x2 and y2. So applying our formula, y2 is 1 minus y1 is 7 over x2 is 3 minus x1 is 1. So 1 minus 7, that's negative 6 over 2. So negative 6 over 2 is negative 3. So the slope of this blue line from 3 to the left of 3, as far as our graph shows it, that slope is negative 3. So that's the first thing we're looking for. The derivative, wrong color. The derivative, that is f prime at 2, is negative 3. Now what about g prime of 2? That is the slope of the tangent line of g at x equals 2. Again, g is a linear function, so all we have to do is find the slope of this red line at x equals 2. Well, let's pick a few points. We know that point is on the line. We know this point right here is 3, 5. Oh, you know what? I mislabeled that point. Did I use that point? No, good thing I didn't use that point, because that point is mislabeled. Sorry about that. Alright, good thing I didn't use it, because I wrote it backwards. It's 2, 4. Not 4, 2. Sorry about that. Okay, but we didn't use it, so no harm, no foul. So here's a point on that line, and here's a point on that line. That looks like 1, 3. And then we have, looks like 0, 2 over there. So we can use any pair of those points to find the slope of this line. Let's just call this one x1 and y1, and let's call this one x2 and y2. So if we apply slope formula again for this red line, we can say m equals, okay, let's see, y2, so that's 3 minus 5 over 1 minus 3. Okay, so let's see, that's negative 2 over negative 2, so that's 1. So g prime at 2 is 1. So the sum is negative 2. Okay, we can solve another one. What about if we want to solve, say, f prime of 5? We can probably do that. That is, we want to find f prime, lowercase f prime at 5 plus g prime 5. This right here, that's just the slope of the line above x equals 5. The slope of f above x equals 5. This right here is the slope of g above x equals 5. So let's see if we can do this without actually doing the slope formula. What's the slope of f above 5? Okay, let's see. Let's pick a point. You go down 2 and over 2. So you have a rise of negative 2 over a run of positive 2. So it looks to me like negative 1 is the slope. Negative 2 over 2. So down 2 and to the right 2 gives us a slope of negative 1. Negative 2 over 2, which is 1. What about g prime at 5? Oh, that is g. Sorry about that, guys. I messed that up. Negative 1 is g. Okay, that's the red line. What about the blue line? So the red line is negative 1. What about the blue line? Let's see. Let's pick this point here. If we travel up 2 and over 2, that's 2 over 2, rise over run, we get positive 1. So the slope of f, which is the blue line, at 5, plus the slope of the red line, which is negative 1 at 5, you get 0. Now soon here, maybe in the coming sections, we'll have these same type of questions, except we'll have scenarios like this, where capital F of x equals f times g, or maybe capital F of x equals f divided by g. Now at that point we'll have different rules for how to deal with the product of two functions, or of how to deal with the quotient of two functions. Okay. Now just to give you a little preview, Like this one's going to end up being, we have to have f prime times g plus g prime times f. Okay? And so we'll have to find this thing, this thing, this thing, this thing. 4 things. Here we only need to find 2 items. Here we have to find 4 items. For this, we'll have to find, let's see, f prime times g minus g prime times f over g squared. Now, again, this is for another lesson for another day, but here's how we're going to evaluate products and quotients when we have a quotient or product of 2 functions. So that's where we're headed, but we're going to do this exact same thing with products, quotients, compositions in the coming sections. So get really comfortable with this. I like these questions because they really test your understanding of, first of all, how to employ the properties of derivatives, and then secondly, what a derivative means. And what a derivative means is a slope of a line at a certain point. So the slope of a tangent line, which is synonymous to the slope of a line at a certain point. Hope this has been helpful. If you have any questions, let me know.